And I'm lucky enough to be involved for a long time with mass timber. The first time I tested a glue lam connection at a fire test was 30 years ago. So I've had 30 years of burning timber and learning how it fails, and have done an enormous amount of fire testing through my career. And I think that's important. And it's important for me to be able to try and get some of those messages across, and also the learnings from that. And so I'm trying what I can to be able to do that. And I think those are really important things to be able to do. It's for us to be able to ensure that the industry continues to grow. It's about architects, engineers, contractors, developers, all understanding the material and get to the point where you can make educated decisions to build a mass timber building.
This is the Mass Timber Group Show. I'm Nick.
And I'm Brady, and we interview sustainable building experts. Today's guest brought all the answers about the relationship between fire and mass timber. David Barber is a principal and fire protection engineer with Arup. He helped us answer some of today's toughest questions regarding mass timber and fire. David's been working on fire safety and engineering for over 25 years. He's published papers on the subject, and he's been asked to speak on the topic for some of the biggest organizations in the mass timber industry.
We talked about the Arup Empire, a $2 billion company that was founded in 1946. We talked about how David got started in the industry 25 years ago and how you can do it too.
Before we dive into it, if you want to hear more sustainable building experts share their stories, insights, and predictions, please hit that subscribe button. So with that, let's get into it. So tell us, David, everybody knows that wood burns, and yet we're using mass timber to build 20, 25 stories up. Aren't we creating some sort of major fire risk here?
Yeah, well, the perception is that, but actually, it's not. And I think that's one of the real things we, people like myself and a lot of others in the industry have to deal with and have to help educate people on, because, the risk isn't there. It's, there's a hazard with all construction materials with fire, and we have to deal with fire as one of the hazards, whether it's snow or high winds or floods. We as engineers design for hazards, and seismic design, earthquake design is probably one of the hardest types of hazards to deal with, and fire is another one of those. So, and we have to deal with different materials, whether it's concrete or steel. In this case, obviously, we're talking about mass timber, and there's obviously a number of other different construction materials. So we design things on the basis of understanding how they work, how they can be successful in opposing that hazard, or how can and how they fail in opposing that hazard. And we then can bring those materials together in a way which means in some ways they are stronger than the individual elements. And I think that's important for all types of buildings. We see that where we can, you see that from an architectural engineering point of view, we can bring those materials together and create something which is, incredibly strong and incredibly resilient to whatever the forces are. So for timber, it's a similar sort of process. It's sort of a well sort of walked path, I suppose. And especially for timber, we've been doing it for a long time. We've had timber buildings for thousands of years. So we've seen the successes and we've seen the failures. And so in some ways we understand how timber reacts to floods, seismic forces, and fire as well. We know how they fail. And the big difference that has occurred in the last 10 years or so, really, because it's been quite recent, is the materials we're using, and the fact that we're using, in some ways, stronger materials and materials that allow us to build taller, whether that's Cross Laminated Timber, CLT, which is, because it's a panel, it allows us to have a more efficient floor system, and also the way we have engineered glue lam, and glue lam is not in some ways it's not a new material. It's been around for more than 100 years, and other engineered timbers as well, and to be able to bring those together. But importantly is the connections. In some ways you can, imagine for the last 30 or 40 years, we've had long span glue lam, and we've seen a lot of long span glue lam, and we've been able to create really large glue lam sections, but the technology, the screw technology, the connection technology to be able to put those together in an efficient and very strong ways, but incredibly, like an incredible step change really, that has allowed us to build taller and taller buildings. And fire is part of the process of understanding, how those materials fail and how we protect the buildings to ensure that they are fire safe. So it's like long response there, but I think it's important that everybody understands that we have to deal with, those hazards for all buildings. But there's part of it is that the technology and the materials, then part of it is obviously understanding how those materials can be successful against, the hazards that they face.
And so you're a fire protection engineer with Arup, and so you deal with this kind of stuff all of the time. Can you tell us a little bit about what a fire protection engineer does on a daily basis, and then how you got involved with Arup?
Yeah. So there's different types of fire protection engineers. In some ways, I have a background which is more structures focused, and obviously my focus is mass timber, and there are others who deal with fire protection side of things. In some ways, sprinklers and pumps. There's people who deal with high hazard type fire protection, oil, sort of, hazardous fuel storage, which is, the really large fires, and that's pretty complicated stuff. And there are people who deal with smoke control and fire, other types of fires. So there are people who specialize in certain areas, and there's people who are sort of more generalists, I suppose, as well. And we come from different backgrounds. And I think that's one of the interesting things about the fire protection side of things. Mechanical engineers, structural engineers, electrical engineers, a wide range of different engineering backgrounds, but also there are people who are architects who get into the fire side of things. People who are involved in materials and chemistry get into the fire protection side of things. So, and so there's differences that are needed for all types of work. And I'm, from a consulting point of view, I work on the building side of things, because buildings interest me. Other people are into, manufacturing and processing, and, there's a broad range, because fire impacts obviously a lot of different parts of people's life. And of course, there's a whole different field of research as well in product development where fire protection engineers are involved in that as well. So, so my background in some ways is slightly different. I've always had an interest in the timber side of things, and especially the building side. Grew up, my father was a carpenter. I helped him building houses, and so I had an interest in how timber goes together, especially, what we see now as light frame timber, and was involved in that. And then ended up going to university and studying structural engineering and studying the timber side of structures. And that was how I got into the field that I'm now in. And at a point made a decision that the fire side of structures was actually, really interesting, and studied the fire side, how fire affected timber, in the same way that people now have an interest in how fire affects timber. I had the same interest. And so I've been involved in the, how timber gets involved in buildings for pretty much my whole career through. And a lot of that used to be light frame timber, and have still even now get involved in buildings which are light frame timber. And I think a lot of people are involved in mass timber nowadays actually started off, typically a lot of them, with light frame timber as well.
There's incredible projects. I mean, it would take all day to kind of list the projects that Arup is involved with. I mean, I don't know if this is already outdated, but if you take a quick look at Wikipedia, I mean, it's a $2 billion company, over 17,000 employees, 90 offices in 35 different countries, 160, you have projects in over 160 countries. And please, and so if people don't know, it's arup.com, pronounced Arup. And I don't know, how did you fall into such a cool company? And maybe, if people are interested in learning to know more, or even like a young, person wanting to get involved in the industry, how would they do that?
Yeah. Good couple of questions, I suppose. I've been on the fire side of things that when I first started, and I'm now 25 years this year working for Arup. So I'm kind of one of those strange people who've worked for one company most of their life. A lot of us don't exist now, I don't think. But there wasn't that many companies that actually specialized or had a whole group of consulting engineers who actually looked at fire. And so, but Arup did. And so I actually wrote to them and actually just said, look, I'm interested in doing this, and ended up getting a job, which I was quite lucky in some ways to do that. But I sort of sought them out, and have since then I've worked in a lot of different countries, worked on a lot of different projects, and have taken opportunities to do so. And I think I've had quite a rich career, because I've traveled quite a lot with the company, and also taken opportunities where I can. And I think, I would suggest that all engineers should do that. I mean, traveling while working is actually, a great thing to be able to do. It's stressful. It's hard work. You have to put yourself in some often quite challenging situations and projects and locations. There's something like sitting in a room full of, a whole lot of people smoking away and, having to sit there and listen for hours on end of people talking in a foreign language and trying to understand what's going on and then present back to them. But it kind of builds some character for you. So, and I think, any young engineer, I think they've got to, don't be concerned about some ways where you start, but I think also you've got to be able to look for opportunities in different locations. And I think the ability to travel and work in some strange locations or some boring locations can be, quite, really sort of, quite rewarding for your career. So, don't look for a company which is down the road. I think people should look for companies, outside their city, outside their state, outside their country, and try and do something different.
Good advice. You talked a little bit about some of the projects. Well, I mean, how there's been some cool projects. Anything come to mind that stood out for mass timber in general, or projects that maybe you studied that just kind of wowed you?
Yeah, there's been some interesting. A lot of the ones I find, in some ways, some of the smaller ones are actually kind of interesting. A lot of architects do some really clever things sometimes with smaller projects, and it's kind of sometimes, there are things we do which you never see, and that's part of the success in some ways. Is some of the really good engineering we do, no one will ever see it, and it sits behind a wall, or it sits in the building, or it sits somewhere, and it can be really rewarding for us, but no one actually understands it except maybe a small group of engineers or an architect who does, and that's unfortunate because in some ways you can work on some very large and interesting projects, but actually sometimes some of the more interesting engineering wise are actually some of the smaller ones. So in some ways, there's a building at the moment which is just being finished off, and it's in the UK. It's outside of London. It's in a place called Charlton, and it's called the Workstacks, and it's basically a four or five story office building. It's quite small. It's all CLT, and it's got a lot of cantilevers with it. And it's really interesting building. It's kind of, there's a sort of an architectural theme of having a stepped cantilever, and there's a number of buildings, sort of quite famous architectural buildings with that. This is the first sort of mass timber building sort of replicating that. So, it's called, as I said, it's called the Workstacks building, but, it looks interesting. It's not huge, but there's some really clever engineering that's gone behind that structural point of view and from a fire point of view. So being involved in some of those smaller projects can be quite a challenge. And, often they're done on a smaller budget and a smaller time frame, but, that's where it's kind of, it can be a lot of fun.
How did we go from building everything in the world with wood, even in big major cities, and then we had kind of like a hard turn into steel and concrete? What drove that transition?
Yeah, well, I'm not quite sure I could explain all that, and I'm not quite sure there are probably people out there, historians, who probably can. I wonder at the same time myself sometimes and about that, because there are certain cities in the US and Canada where there are still tallish mass timber buildings, or historically heavy timber buildings, which are still in place, and they're great to kind of source them out, and they haven't. They're still there. They haven't been demolished. They haven't been pulled down and replaced by something which is 30 or 40 stories in concrete. And I do wonder myself about that whole swing. And I think part of it is construction, and the way that construction finds in some ways the most efficient way to build. And it's probably about typically all these things are about how the cost involved and those sort of things, and what becomes perceived as being the best and easiest way to be able to build. And in some ways that battle between concrete and steel goes on, where you see, cities where it's still predominantly steel construction, cities where it's predominantly concrete construction. And, on the East Coast, DC is a concrete construction town, and, you don't have to go too far up the road before you get to Philly and New Jersey and you see a lot of steel work and you kind of go, well, why, that's geographically, 2 or 3 hours apart. And why are they so different in the way they build? And there's obviously reasons for that. And, it's kind of, there's an interesting, I think, process in the way that we build, and the way that certain markets become very driven by certain materials. I assume that's, obviously partly driven by the supply, but partly driven by probably some contractors who are very strong in that. And they push that in certain, organizations from a development side of things who want certain buildings, who, try and make sure that they get built that way. But it's positive to see the change and the real need to change and to have, timber as an alternative. And it will always be in some ways an alternative material. There's, we kind of hear sort of people talking about the fact that mass timber is going to take over. And I think that's probably never going to happen, unfortunately. I mean, it'd be fantastic if we did have a lot more timber buildings, because we need to have, better buildings in some ways. And, buildings which are a lot more responsible from where their materials come from and how we use materials. But the reality is that, we're still going to be building out of concrete and steel. But, it's certainly positive for us to have more mass timber buildings that are medium and low rise, for those, a lot of medium and low rise buildings, but us also to have buildings which can be at 8, 10, 12 stories, those sort of size, where there is a significant market, especially for residential, and the need for more residential buildings. And I think that's certainly something which, we should be seeing a lot more over the next 10 to 20 years.
One of the things that we've heard a lot about why mass timber buildings haven't caught on as much as maybe they can, or the opportunity presents itself as, is fire concerns, whether that's insurability or just it's wood. People just are afraid it's burned. But there's been a lot of testing that's happened and proven its effectiveness in fire. Can you tell us about some of those improvements that have happened recently?
Yeah, and I think, again, the issue is partly perception, and around, the concerns around mass timber and concerns around timber generally are around fire. And I think, there's obviously, we do have to address those. We have to address the fire risk, but we also then have to make sure that it creates a situation where we can build with it safely. And, part of that is driven around, we have, as I said, new products, in some ways, relatively new products. And then the question is, how do we put those together in a way which allows us to build safely? And we have, testing, and we have test standards, and all materials have to meet those test standards. And in some ways, building codes are around, in some ways, generally independent material. And then the test standards that they reference and we have to use are also primarily written independent of the material. So if you've got a product and you want to be able to build with it, then there's a process you have to go through, and the code provides you with that process, whether it's fire resistance ratings. And if you want to build a certain height or a certain type of building, you'll have to meet a fire resistance rating, whether that's 1 hour or 2 hours. And then from that, it explains very clearly what the test standards are that you need to meet. So you've got to then go through that process of testing that material to be able to meet those standards. And so, that is all very clear, and every material that is being used as a column or floor needs to go through that process. And so a lot of this has been the fact that in some ways you need the market to be in place, because testing and product development is expensive. And so you need the market to be able to want, producers to be able to then spend the money on the testing to then be able to then provide the materials you can build with. But in some ways you need both. You need the material and you need the market, because, they've got to be incentive for each other, because everyone's going to spend the money. And so a lot of that is around, how do you get that over that hump? And so investment by, sort of in some ways, government organizations, state or provincial organizations, private organizations, to help suppliers carry out that testing, and to help get, important things like code changes as well through, have become really important. And we've seen in some ways quite an acceleration of that over the last 10 years or so. And that's partly driven by the fact you've got a market need and there's a market push to have more sustainable building materials and some ways more responsible building materials. You've got suppliers who want to enter a market. And so that's starting to occur where you get a lot more of that momentum and change. And you need the right investment for that to occur, which has occurred through USDA. There's a lot of investment in Canada through both provincial and federal, as well. And in some way, as a North American sort of economy, that the timber economy has certainly benefited out of that. And we get the products that have been then tested, and we can use them for buildings, and we can, makes it easier for architects and engineers to be able to pick those, put them together, and then be able to create the buildings that we want to create.
So you're saying it's not as easy as slapping a fireproof coating on top of the wood?
Unfortunately not. Wish it was. And in some ways now it kind of is. If you've got a product, the path is a lot easier. And I think because we have, overcome a lot of those hurdles, it is a lot easier, and there is a market. And that's part of the issue has been that if you're a supplier, why would you invest, in some ways hundreds of thousands of dollars in development and testing to be able to create a product, then who's going to buy it? And that's the issue. But now we've got a situation within sort of the North American market where there are so many mass timber buildings going on that actually there are more and more organizations, entering the marketplace with products. And that's where we want to get to, because we still have this issue whereby in some ways we've got more demand than we have supply from the point of view of materials. What we're seeing now is a lot more of sort of some of the global suppliers, some of the European suppliers coming into the North American market because they've seen that, yes, there is a desire to have more buildings. And so they're more confident to be able to go through the process of the testing that needs to occur to then be able to sell their products here. So, and that's really, critical. So, there has been a significant change. And I think, we are in some ways, just kind of starting to hit up the curve of growth, and it will continue, but it has needed that initial, in some ways, push. And we are still short of, in some ways, tested and approved materials, but as, the research side of things and industry doing doing the testing has been incredibly valuable to actually allow us to build the buildings we can now.
I think most people out there are just flat out scared about mass timber because for whatever reason, they're not used to it. They haven't been educated on the fact that they think that it's just going to go up in an explosion of flames because everything around them is wood, and wood burns, super fast at maybe the campfire site that they've been around, or you spread some gasoline around and it just poof and it's gone. Maybe it's a double-ended question where is it as simple as creating, let's say, a cross laminated timber panel, CLT, where you have commonly a 3, 5, or 7 layer ply panel, is just the thicker the panel gives you a longer fire rating, and it keeps fire, it keeps the structure more structurally sound. And if so, what does keep the fire from rapidly entering into the core of the mass timber panel in general? How come it takes so long for the structure to burn down?
Yeah, there's a lot to sort of unpack in that statement. I think first of all, from a fire spread point of view, timber actually doesn't burn that rapidly. Timber is fairly, it's a well-known product. We all know that timber burns, but in some ways, if we compare it to other materials which we know burn, like plastics and furniture and in some ways, curtains on a wall and other materials, it's not at all as flammable as those, and that's an important thing because we see this issue around combustibility and non-combustible versus combustible, and sure, timber is combustible, but there is an enormous range of items which we put into a building which are combustible. And the timber is some ways at the boring end, and not much happens with timber. You've got to we know a certain amount of heat needs to go into timber for it to burn, a certain amount of flame needs to occur before timber burns, and then it's a natural material, so it doesn't burn sort of in a dirty way. You don't get a lot of toxic chemicals coming out of timber as you do when you burn certain plastics or, certain petroleum based, materials which we put into houses. I mean, the flat screen on the wall is when they burn, any sort of TV is the toxics, smoke and the chemicals that come out of burning a TV is pretty poor. And you compare that to other natural products that you're putting into your house, there's a significant difference. So I think that's one of the things that is useful from an education point of view for people to understand that combustibility has a significant range and what we build with, and what you choose to put in your house obviously can have a significant influence on what burns as well. But then, secondly to that, we're using timber as furniture, and we're using it as structure as well. And what I deal with is the timber as a structure. And in some ways, when timber is exposed to fire, it does start to char, and there's this sort of magical sort of aspect which occurs, and we see it in a lot of documentation, a lot of media reports and those sort of things. But yeah, timber does char when it's exposed to fire, and we see that in campfires as well. And it is a protective layer. I mean, you see it in forest fires, the timber and the trees basically, they char, that protects the inner material. It still has the moisture it needs to continue growing and continue living. And when we have engineered timber, we still have that natural ability for timber to char, and char is an insulator, and that insulation protects the inner core from the heat. And the question is, from our point of view, is how we use that, in the same way that we use, the advantages of concrete as a sort of inert, non-combustible material, to resist fire. And we do that with reinforcing steel, and we design the concrete to resist fire. Steel sections, we put board products around those, or paint products or spray products, and they basically protect the steel, and we make sure that the steel stays at a reasonable temperature. For timber, we're using the char layer, and it is in some ways the larger the actual the depth or the thickness of the timber, it allows us to design from an engineering point of view, because we're doing two things. One is we've got to be able to, say for a column, it's got to withstand a certain amount of load, and obviously the taller the building, or the larger the floors, the more load that column has to withstand. So we understand what the minimum size of that member needs to be. And then what we can do is actually understand how much char we need to include to increase the member size to ensure that we can resist a fire for 1 hour or 2 hour, whatever the value needs to be based on building code requirements. So a steel column will have to meet a 2 hour fire resistance in a building, and a timber column would need to meet a 2 hour resistance in the same building. And so the materials we use and the protection we use in some ways is different, but actually, they still have to be tested to the same test standard. They still have to have the same, fire resistance under the code. And then how we protect those will differ slightly, but in the end, what we're trying to do is make sure that timber element is designed and engineered to stand the fire it needs to. Size, increasing size is important for load, and that's the same for all materials. And then we also increase the size to ensure we get the right fire resistance as well.
You mentioned designing to specific code standards, and America's been very quick to adopt mass timber into their building codes, but we're still relatively young in that cycle. And we all know that different municipalities are in different versions of the code. What kind of challenges does that present when you're working with mass timber?
Yeah, and I think there's a couple of things. First of all, we have had mass timber or heavy timber within the code for as long as we've had codes. So it's, the heavy timber part of the code has actually been around for a long time. So there's a nice history within the code of having larger timber members. So that is important, because in some ways, whilst not every building official may have worked with a building that's always had heavy timber, it's always been in the code. So and then what we've done is we've used that basis of that in some ways that foundation to then be able to build to allow us to do two different things. One, we've modernized that more recently in the 2021 building code, and we've got more modern versions of, in some ways, the historical part of the heavy timber part. And then we've allowed that to have taller buildings as well. And the 2021 IBC was a significant change to allow more modern sort of what we're building, mass timber buildings, and codify that. And there was a lot of work that was gone on to actually allow those code changes to occur. There was a lot of committee work. It was a really pretty interesting bunch of people who got together to be able to make those changes occur. And a lot of work went on to behind the scenes to get to that point. And that change from having, in some ways, medium rise mass timber or heavy timber to high rise has been quite a change. And not every jurisdiction has adopted that code. And across the US, between cities and within states, we have different code adoptions, and then we have local amendments to codes as well. So you can have now a situation where we've got locations where we're still on the 2012 IBC all the way through to, cities that are adopting the 2024 IBC. So, which is, and currently getting close to being printed. So, that's an enormous range. And the building officials and the fire departments have to work with that. And it's not just the building code, the fire code and mechanical code as well. They need to be able to understand the code that they work with, but also understand typically, in some ways, the previous version, because they still have buildings coming through, they've got to approve, and often the people are wanting to design to the next version as well. And then you got people like me coming along and sort of saying, well, you're on the 2015 code, but I actually want to look at designing to a 2021 code. And then, trying to help them through that process, because that's what we see. We see architects and developers who want to build a mass timber building, but the local code is not on the current code. It's not on the 2021. It's not on the 2024. And so that's a challenge for them. And sometimes we kind of need to go backwards a little bit and work through what are the issues to be able to get everybody up to speed to the point where we can use the current version of the code. So it does create challenges. And, there are certain, locations where it is a lot easier to build a mass timber building simply because of the code version they're on. And there are locations where it is a lot more difficult simply because of the code versions they're on. And, a good example is, CLT wasn't, written into the code until the 2015 version. So there are, those are problems we still have to deal with even today, though, building officials and fire departments know that those sort of things can be dealt with in a relatively straightforward way. So the code can be a hurdle, but often it's more the case of, if you've got building officials and fire department officials who are willing to work with you, you can get around those code problems quite successfully.
It sounds like, any given city in, any given city in the United States or pretty much any country compared to any other little town could be wildly different. How does a person push that envelope forward? And maybe, like, is it the engineer? Is it the architect? Is it the builder that needs to go to the fire department? Do they go to the city and say, hey, they're doing this in Denver? I mean, I know Greg Kingsley from KL&A Engineers and Builders here in Denver. He's who connected us. And so we can't thank him enough, but he was a real leader in pushing that envelope forward. So who would be the person to go to their specific city, and who do they need to talk to kind of get, up into, into the future ranks of what we're doing right now?
Yeah, it's actually a really good question, because it sometimes can be quite hard to work out how to go to. And typically it's normally always, the chief building official. And they start off with just the building official that and have dealt with on your last project, because everyone from an architectural engineering side typically knows the building officials in the city that they're working with. Can be a little bit more challenging if you've got working on a building in a location where you've never worked before, because you have no, connectivity with the building officials. But yeah, you talk to the building officials, and that's what I spent a lot of time doing is, talking to building officials, to try and talk to them about mass timber. And for some of them, it's a question of, the codes that you're currently on. How do we look at, trying to work with potentially a future code. And then sometimes it's more within the code that they're working on as well. How do we try and fit this timber building into the code, that's actually in place? And, we want to find a way that allows buildings to be approved, so they can be built. And that's, I'm always about, the best building is one that's actually built. And to be able to do that, you've got to be able to make it easy to be approved, because it's easy for everybody if it can be approved from a timing point of view. And, just to be able to get the building started out of the ground. So you've got to work with the building official, you've got to work with the fire department to be able to see how best to make that occur. And they're always willing to work with you. I think, there's often a view that, a lot of building departments are in some ways a bit of a mailbox, but they're not. The people there are knowledgeable, they know their job. Typically the biggest issue for them is they're overworked. They've got so much work going on, and it's more the case of having the patience to be able to, it does take time to get a meeting, does take time to get in front of them, and it may take some time to get a response back, but you'll get, the response that's relevant to them to come back. And, you can certainly, have a discussion, have a dialogue, and try and work out what that compromise, situation is to be able to get a building approved. So absolutely start with the building official, and, they'll help you out to be able to try and, get your building progressed.
So there's been a ton of advancement in the mass timber industry in general, but specifically in the building code area and fire science and just our understanding and adoption of this new material. What's still on the horizon for mass timber and fire? Is there anything that we're still trying to figure out, things that you and your fellow peers are working on?
Yeah, there is. There's a constant need of, and in some ways it's small and large. And that's the part that I find interesting, is where, we're still trying to get our heads around like small gaps and small joints. And from a code point of view, sometimes, when you look at the code, there are so many elements that go into a building, and you can change certain things, but sometimes you don't get down to some of the, really minor details, and things like gaps and joints and how we interface timber elements still hasn't quite been solved in the code yet. And that I expect will start to occur. And then part of it is also the products that go into those. There are a lot of those around, but, a construction joint is a construction joint, and you bring two materials together. And there's, 50 different solutions for a construction joint that are out there, but there's not that many for mass timber. And that's partly driven by the fact that, again, the suppliers need to have a marketplace. They need to be able to then test the materials, and then they need to be able to make sure that it can work. And you've got all these different architects and engineers saying, I want something for this, but next time they want something for this, and it's different again. Next time they want something for this, and it's different again. So we still need to keep working on products that are tested and can be used for mass timber buildings, which are, easy to use, and we can specify, and they're tested for those typical sort of joints and sort of interface areas. And it sounds kind of boring, but it's actually really important, because if we know we don't have a product, we end up having to design around that, which can mean, redesigning how we sort of put a building together, which means it's slightly inefficient, which adds cost to the building. So, those are the things I think which are really important. And then there's sort of larger things as well. It's, at the moment we've got, a code which says we can build up to 18 stories, 270 feet. The question is, why can't we build taller than that? The Ascent Tower has proven that we can build taller than that. And the code has been really positive at getting taller mass timber. The question is, when do we go to the next step? What is the next step as far as height goes? And then, how much timber can we see in a building? And that's a really complicated question as well, because in some ways, mass timber becomes a lot easier if you cover it up with a non-combustible board, and you have the timber not being part of the fire load. And so it becomes quite an easy, in some ways, quite relatively easy solution from a building performance point of view. As soon as we start to expose the timber and expose it to the fire, it becomes more complicated. So we've got to work out how we do that in a way which is adequately safe for taller and taller buildings. And so that's an ongoing area of research, which, we've known about. We know that is an issue. And the question is, how do we best solve that? And, that I think is the next big step change is height. And then how do we expose more of the timber at height as well, which I'm pretty confident we'll get there. It'll be, a compromise solution. And I think hopefully we'll get to a reasonable solution, but we can do it now. So, we've just got to be able to work out how to start to bring that into the code. So, so I think there's everything from, how do we get to sort of 30 stories in the code to how do we adequately seal small joints, in some ways, a little bit of everything in between. And it's partly research, partly product as well that needs to occur.
There's, we're at 25 stories right now with the Ascent building, which is unbelievable. Is there an upper limit to this thing? I mean, can we just cruise right through 100 stories? I mean, where does this thing stop, do you think?
Yeah, I, in some ways, like everything, it comes back to sort of economics in some ways. I mean, I think, in the end, there is a limit. And I think at the moment, it's interesting that, 10 years ago, we wouldn't have been able to build a 25-story timber building. We talked about 25-story or 30-story, or even 20-story timber buildings. But there has been such a growth in the amount of research that's occurred, the amount of testing that have occurred, and the amount of building that has gone on to allow us to then build taller. And in some ways, it's kind of like a bit of a pyramid. You need a really good base of good sort of low and medium rise buildings for a lot of people to learn on, and having tested products and having them used and learnt how well you can use them. And then, it allows you to build sort of medium rise buildings and, sort of, I suppose, low high rise buildings, those kind of 10, 12 story buildings, which are sort of a really good building block in some ways to understand for the engineers, the architects, the contractors, importantly, and the product suppliers to work out how to do those. And not just in the US, globally, because in some ways, the mass timber design and supply community is a global community, and we do operate in some ways as a very global community. And so we've needed that development to occur in Canada and the US and in Europe as well, where there's been significant amount of growth in height of mass timber buildings as well as the number of mass timber buildings. So the same process on both sides of the Atlantic has gone on, which is really positive. Places in Australia have been building more mass timber buildings and taller mass timber buildings, and again in parts of Asia looking at it as well. So that has meant that you get to the point where you can build a 25-story mass timber building. And I'm pretty comfortable we can build a 30-story mass timber building and do that in a very safe and well-engineered way. The question is, above that, yeah, I'm not 100% sure. I'm not 100% sure we need to either. I expect we will be seeing 40 and 50-story timber buildings. They will be hybrid buildings, all these buildings which are more than kind of 7 or 8 stories, typically are concrete or steel or timber hybrids. They're never all pure timber. So it's a combination of how do we use those materials in a sensible way. And I think what we're seeing is that some of these buildings in some ways are often a lot of concrete and certain amount of timber, and they're called a timber building, but actually a lot of it is actually concrete. And I think we've got to understand that as well, is that what it's represented as is often not the case. And some of the more pure timber buildings, and there's a few of those in Europe and in Canada, as well as, some of the Ascent is, very close to being a pure timber building. It's concrete elevator and stair shafts, and the lower floors of parking are concrete as well. But, there's a significant majority of that building is timber. I think are really important for showcasing and the engineering and the technology that we've got now to be able to build that tall. I think as we go taller, wind becomes harder, the loads become harder to deal with, seismic design becomes very hard at those heights as well. So we've got to be making sure that we're doing things in a very safe way as well. And I expect we will probably see taller buildings occur. I think that's a positive thing, but I think importantly, we've got to see more buildings at 8 stories and 10 stories and 12 stories. And we've got to see a lot more medium rise buildings in a lot of other markets. And that's, where we should also be aiming for. And making sure we can build those efficiently, approve them efficiently, and, allow contractors to decide, I can build it out of steel or I can build it out of timber, and looking at the options going, actually timber's a better option. And that's what we want to be able to see.
Sure. Right before we hit record, we were just small talking a little bit, and you mentioned that traditional stick frame or stud frame or light frame construction is harder to build than mass timber. And can you explain why you think that?
It's I think anyone involved in sort of a timber stud world, light frame world is would certainly probably sympathise. When in some ways it's very easy to have the same stuff which you can build in a 2 or 3 story home, and in some ways it's been done for so many years and we all know how to do it. In some ways you don't think about the engineering or the architecture that goes in it. So highly standardized. You're putting it together in some ways, and it's all about the efficiency of it, and in some ways slightly different products, but we've been building the same thing for so many years. When you look at 4 and 5 and 6 story light frame construction, each of those buildings in some ways is sort of the same, but all of them are different, and all of them have a lot more complication because we've got a lot of loads coming down. We've got to deal with, typically on the West Coast as well, we deal with a lot of seismic issues, and that's tough with light frame. And moisture control which is always an incredible amount of detailing that's needed to make sure we're dealing with moisture becomes even more important when you're on, multiple stories and multiple, floors of a building. So the overlap of the acoustics, the moisture control, the fire control, the buildability, and sort of in some ways the standard details we have means that it becomes very hard to be able to build some of these buildings and do them in a way which still fits what we want from a code perspective and allows, the engineers and the architects to produce what is needed for the guys who are on site basically with nail guns and, throwing these things together in the most efficient way they can. So, you get a lot of smaller details or a lot of small problems to deal with. And some ways from my point of view, it's helped me incredibly to deal with mass timber buildings, having a background in light timber frame, because you deal with all these small problems. And there's lots of small problems, and a lot of them kind of quite different corners and different balcony details and setbacks and, what we see, architecturally now with a lot more sort of articulation of facades and things, that you have a lot more of those issues. And then it's, mass timber, we have a lot less of that. We deal with sort of a bit more uniformity in the building and a little bit more uniformity and rectangularity in the building, and also obviously a lot less in the amount of connections and interfaces and those sorts of things as well. So, and as I sort of said earlier, there's a lot of architects and engineers and contractors who are involved in the mass timber side of things who came from a light timber frame background, and I think that helps you. And I think having that sort of understanding of how small timber goes together helps you with, big timber problems.
So you've been spending the last 2 decades working on your craft, working with Arup. What's next for you? What's next for David?
I think timber buildings are still getting built. People are still wanting to build taller timber buildings. So that's kind of interesting. People still want to do crazy timber buildings, which is kind of interesting as well. From my point of view, there's a few things I'm trying to continue to work on timber buildings, which are interesting. And continue to kind of be involved in education and awareness and trying to help the next, I suppose, step change that occurs with timber. And it's not just about fire, but it's about how we make timber more readily available as a building product. And as I said earlier, you want to get to the point where developers and contractors, because often there's both sides, are looking at, concrete option or timber option, steel option or timber option, and actually saying, this is a better option. And how do we get to that point? And what is the process that needs to occur? And, fire is part of that. Codes are part of that. Product solutions that go into that are part of that. So is the architectural side, so is the acoustic side, the structural side, the waterproofing side. So there's a whole lot of work that needs to go on. And so, I want to make sure that we're trying to do that from an industry point of view. We continue to need to educate architects and engineers and everybody involved in just basic understanding of mass timber, like what you're doing right now. I think is really, really positive to be able to provide everybody with an introduction to some of these issues and all the important parts that go into, why we're seeing more mass timber buildings, and that is important. And then sort of those other levels of education, whether it's at university level or whether it's, specific information and training for engineers on fire design and the complexities of how we engineer, I think are really important. And I'm lucky enough to be involved for a long time with mass timber, and, I'm coming up close to, the first time I tested a glue lam connection in a fire test was 30 years ago. So I've had 30 years of burning timber, for the sake of burning timber, and learning how it fails, and have done an enormous amount of fire testing through my career. And I think that's, important. And it's important for me to be able to try and get some of those messages across, and also the learnings from that. And so I'm, trying all I can to be able to do that. And I think, those are really important things to be able to do, because, it's for us to be able to ensure that the industry continues to grow. It's about architects, engineers, contractors, developers, all understanding the material, but understanding the next level as well. Not this introduction. They need to work on buildings. How do you, make sure that they understand and get to the point where you can make educated decisions to, build a mass timber building? And how do we make sure that we're getting that to occur? Because the disappointing side from my point of view is I've worked on a lot of mass timber buildings that haven't been built. And I think that's the hard part for me. There's an enormous amount of work that goes into early design, early sort of planning of timber buildings, and they go through, 10%, 20, 30% design, and then they stop. And we need to get more of those across the line. And so that's, I think really important for the next sort of 5 to 10 years of the industry.
Speaking about learning, it sounds like you're 30, 40 years into this industry, so this might be a little difficult, but if you could look all the way back into the beginning, or even in the last, few years, is there any books, podcasts, maybe some academic course that you took that just changed it, changed your viewpoint, opened your eyes, and maybe you think other people should also take?
Yeah, interesting. I suppose from mine, there's a couple of things. One is for me, I studied in New Zealand. I'm from New Zealand, and I went to the University of Canterbury, which has been a very much an engineering based university, has a very strong engineering school. And as part of that, structural engineering and seismic engineering is a core topic, which we all learn about. And so, for me, my career very early on was shaped by Andy Buchanan, Professor Andy Buchanan, who's well known in the timber industry, and who, sat me down one day and pretty much said, "Look, you can break some. You're interested in timber. Do you want to break some timber or burn some timber?" And it's kind of like, wow, burning timber, that sounds interesting. So and some of those small conversations around, and everybody's had these, with people who basically help put you on a path. And that was incredibly important. And, last month I caught up with Andy and we had coffee together, and it was great to catch up with him. And I think, he's been an important mentor for a lot of people in my industry, because we need people who are, in some ways these sort of intellectual giants but also who help shape people's paths and help give them some direction about, where things are that need to be solved. And I think, from my point of view, from at a university education level, we engineers spend a lot of time studying and looking at different materials, but I think it's important from my point of view, if I was going to pass on anything as well, it would be, find something that interests you and try and, spend more time studying that. And I think from my point of view, I had an interest in timber, and wanted to carry on studying timber. And so it was a matter of then finding something that interests me. And he, provided me with that opportunity, and I've never kind of looked back since then. It's, that's the timber industry has provided me with a good sort of home in some ways, because there's a constant need for problems to solve. And that's worked out really well from my point of view. But it's a good industry. From my point of view, I think the timber industry is a great industry to be in as well.
Yeah. Thank you for sharing that. It's amazing how conversation with one person can kind of change the entire trajectory of your life, right? Before we ask our last question, we also want people that are listening to this, if they're interested in contacting you, if they've got questions about fire science, if they're interested in working with Arup, one, what type of clients, what type of people reach out to Arup? And then two, how can they get a hold of you guys?
Yeah, I mean, we as a firm work with, work in the building side of things, and we work with a lot of architects and developers, and I think we typically most of our, a significant core, I suppose, of our clients are architects or developers who are wanting to, get into the development side of construction. So, and obviously, contractors as well, depending on the situation of the build and those sorts of things. So, we're a company which is pretty easy to contact, websites, but also, from my point of view, I'm on LinkedIn and it's pretty easy to find. I'm happy for you to pass on my email address at the end of this as well. And I think importantly as well that we see a lot more, especially in the timber industry side of things, a lot more producers and suppliers wanting to contact us as well. It's something I've been involved with for quite a number of years, obviously, is the testing side of things. And I sometimes wonder, in some ways, there is a need for a lot of those suppliers who are involved in or thinking about the timber side of things to actually get the right advice, because sometimes they're not understanding where their product sits in the code and what they need to test to. And we do see suppliers and producers sometimes having products which they've spent money on testing, and it's kind of like, you're testing it to the wrong thing, and this is where you need to be, and this is the section of the code you need to be in. And those are the important parts, I think, in some ways, again, we can provide advice like that. So yeah, I mean, we deal with a wide range of clients, public, private clients. It's, I think as long as there's, people out there who want to, continue to develop and build buildings, we want to continue to be involved.
Yeah, I can see how those would be pretty important conversations to have, especially when you're spending big money developing those kind of products, right?
Yeah, exactly. Yeah.
So our last question is a fun one. If you had the power to wave a magic wand and change one thing in your industry, what would you change and why?
Oh, what would I change? I actually think at the moment I would like there to be a significant step change in the supply of the timber industry. I think at the moment we have an enormous market that could deal or could use a better supply side. And there'll be a whole lot of suppliers who probably don't want me to say that and probably don't like that, because in the end it's all about market share and things. But there is an enormous pent up demand for mass timber. And I think what we need to see is a better supply side. And it's kind of difficult because in some ways getting a tree and turning it into an engineered product is actually quite a difficult process. There's a lot that needs to go on that from a certification and supply side and quality side. But we need to be able to have the investment, I think, from a sort of and it's probably government and private sector to encourage and make sure that we have more glulam, more LVL, more CLT, and also those sort of secondary products which can go into that, screws, connectors, sealants, all those sort of things. And that would make us an enormous change and would mean that we could actually, I think, build significantly more low and medium rise timber buildings, because I think that's, what we need to be doing. And so to me, I think if I could change things, I know it's kind of maybe not the most interesting thing in the world, but if we could change and improve the supply side of things, I think we would see a significant change in the way that architects and developers think about timber, because it would become, there's a cost element to that, but I think there's also an easy to build element, which would start to come into that as well. And we would see timber become more of an equal or even a better, a better product from the point of view, if you're building a, 4-story office building in, a suburban, location, timber could be and probably would be the better option. So, that's what we need to get to. And and maybe we will get there, but it's interesting that sort of 10 years ago, that one of the constraints for North America was timber supply, engineered timber supply. And here we are sort of 10 years later, with one of the constraints still is engineered timber supply. And driven by the fact that the market just keeps growing. So we need to be able to try and work out how to deal that in a better way.
Before we close, it was pretty cool talking to other peers in the industry. Some of the biggest names in the world were like, I was letting them know, hey, we're going to talk to David Barber. And they're like, oh my gosh, we're excited for the episode because you are at the forefront of, fire safety for mass timber in general. What's on the horizon? Or do you go to, specific events? Where can people also meet you in person and just kind of talk the breeze?
Yeah, well, thanks. Thanks for this little compliment. That's very nice. Interesting enough that in the last, 2 weeks or so ago, there was the World Conference of Timber Engineering, which has just gone on, which happened to be in Oslo in Norway. And that was a great gathering of timber engineers and researchers, and was, 4 or 5 days of just timber people geeking out in some ways. And, those sort of events are incredibly important. And that occurs every 2 years, and there's something that people like me really look forward to. The Mass Timber Conference, International Mass Timber Conference, which is in Portland, in Oregon, every year in March, is a great event. I'm always at that. Have been there ever since it first started off, and I find that is a really, really good event for anybody, whether you have no idea about mass timber or you're on your 10th mass timber building. You will always learn something, and you'll always get to meet some other interesting timber people. So I think that's a really important event as well. And then, I'm not at all of these and not involved in all of them, but I think, Woodworks are a great organization, and the work they do in education and product support and project support as well is really important. So, not just me, but other people who are involved in the timber industry, if you do want to learn off others and learn off peers and be able to ask sort of dumb questions in a really supportive environment, anything that's related with Woodworks, any of their education sessions, whether they're online or in person, I think are really, really important. And they're just, they're a great place to be able to understand and learn about all the different aspects of timber and how to build with them. So, I think, from that point of view, there are some really good events going on. But, from my point of view, the real kind of the timber kind of researchy events and the timber sort of engineering events are the sort of things that I typically like to go to. So, because I learn, I just, as I said, spent 4 days at a timber conference, came away with an enormous amount of notes, huge amount of papers to read, always learning. It's a great industry to be in.
Well, thank you so much for being with us. We'll see you at the next event.
Yeah, thank you. Thanks very much for this. And well done, guys. Great podcast, great initiative.
All right, cheers.